Hello all, welcome to pantechelearning and good evening to one and all present here. So today we are going one of the important techniques. So the technique is nothing but like how we can develop the end-to-end project delivery. That is how we can develop the project base paper to machine learning things. So that is what we are going to see about. So once again, good evening to one and all. Welcome to pantechelearning, and I am Kamalesh. I am from pantechelearning. So today I will teach you how we can develop the project, based on the IEEE paper, and then we are going to see about what are the existing and what are the proposed system in that paper, and then we are going to do the project based on that. So this is one of the most important techniques, and you can apply this for your project, that is for your academic projects also. So today I am going to teach you, so just keen watch it, and then from starting to ending definitely it will be useful for you. So it will enter into the session. Let's check the audio first of all. So this program is conducted by one of the institution of electronic and telecommunication engineering, that is IETE. So IETE, the program is conducted by the institution of electronic and telecommunication engineering, is India's leading recognized professional society devoted to the advancement of science and technology of electronics and telecommunication, and IT SCETAR also. The IETE is the national apex professional body of electronics and telecommunication, computer science and IT professionals. It's from Mumbai. So in this today's webinar, so we are going to see about how we can develop the project by based on IEEE paper. So for this webinar we are going to provide some attendance link in description. So if you need for this webinar certificate, you just register in that attendance links and you can check it out. And then we have even inquiry link also. Inquiry link is nothing but if you have any project idea, if you need to implement those idea, and you need to see the for that project you need to implement those project with our faculty members of pantechelearning. Means you can encourage your own project also. It will always welcome to those things, those ideas, and we will definitely develop and give it to you. So we have separate link for attendance, that is for certificate, and we have separate link for inquiry form, and then we have like another one link also, that is for attending the quiz competition. So who are all attending that quiz competition, and who are all first 2 or 3 members who are all correctly answer those questions, for those members definitely we will be give the special certificate to those persons, and then the person who are all win in this today's webinar, by tomorrow's webinar they will give the announcement, okay, who are all win today's webinar, like that they will give some announcement, and then you will be get the special rewards and special certificates from our pantechelearning. Okay, so these are the one of the most important webinar topics, and definitely if you don't know about even machine learning or deep learning also, I will teach you line by line and from basic onwards. Just you can listen it and you can just keen watch from up to 1 hour and 1.5 hour. That's enough. You will definitely will gain some knowledge in this webinar. Okay, so we'll enter into the webinar. The webinar is based on the customer segmentation and using unsupervised learning. So if you are new to this channel, please subscribe the channel and hit a bell icon. Definitely you will be learn upcoming days new things. Why? Because it's a project awareness program webinar. Okay, we are conducting the from starting today 11/10/2022 up to 13 project. Okay, so it's nearly we are going to teach you 13 project from now onwards. Okay, 13 days project related to project awareness, not only in machine learning, deep learning domain. We are connecting on like IoT, SCADAs, and then MATLAB, and then power systems, and then deep learning, OpenCV. Like this, we are having some different type of domains. Okay, so if you need to gain those knowledge for this next 13 days, definitely you subscribe the channel. It will be useful for next 13 days, not only for next 13 days, and we are conducting furthermore webinars based on even colleges also. Okay, so it will be really useful for you, and don't forget to hit a bell icon. It is necessary. Okay, so let we enter into the session. The session is first one, we have to analyze the IEEE base paper. Okay, so I will show you the base paper which I am going to develop the project in this today's webinar. So this is the base paper. Okay, like just wait a minute, I need this hand tool. Okay, so the base paper topic is the data driven customer segmentation strategy based on the contribution to the system peak demand. That is what is the main aim of this project. That is what is the main thing about this base paper is they are using some advanced metering infrastructure. That is in some areas. Okay, so they are trying to find the unobservable customers. Okay, for the monthly billing information. Okay, so for example, if you have like electric meters means, okay, so they are using some special meters for those each and every home. Okay, and they are observing each and every home energy consumption on how the customers are paying the bills and all. Okay, so based on that smart meter, they are collecting some data and they are going to use some other algorithm, and they are implementing what are the customers paying, what are the different type of customers are paying, and who are all unobservable customers of that monthly billing information. Okay, so that is main aim is advanced metering infrastructure, that is AMI. It enables the utility to obtain the granular energy consumption data. That is, granular is nothing but some small amount of energy consumption data, which offers a unique opportunity to design the customer segmentation strategy based on the impact on various operational meter in distribution grid. Okay, so based on the smart meter, they are collecting some various different type of data from each and every home appliance, and then however they are performing some utility scale segmentation. Okay, so they are doing some segmentation process. After those segmentation process, we are going to predict the unobservable customer with the monthly bill information. Okay, so remains the challenge problem. So to address this challenge, we are proposing new metric. Okay, they consider monthly peak contribution. Okay, so they are proposing in this paper they are proposing the new metric, that is CMPC, that is considered monthly peak contribution. Based on this method, they are going to predict the customer segmentation. But in today's webinar, we are going to use one of the most simplest and easiest algorithm, Kmeans algorithm, and we are going to predict the n number of clusters in the data set. Okay, so leave about that. Okay, so in this paper what they are doing, let me see that quantities, the contribution of individual customers to the system peak demand, and furthermore a novel multi-state machine learning based segmentation method. Okay, they are using multi-state machine learning based segmentation method and developing the CMPC, that is customers without smart meters. Okay, so based on these smart meters, they are collecting some information of each and every home appliance, and they are calculating who are all observable customer, who are all unobservable customers in that, using that smart meter data. Okay, so they are using some index terms like customer segmentation, peak load, contribution, observability, machine learning algorithms. So for this paper, okay, so we are going to use the proposed system, that is using Kmeans algorithm. Okay, so about this I will discuss you later a while. Just you see the slides, they are using some monthly consumption distribution, that is consumption of using histogram. Histogram is nothing but this is the graph of histogram and how the data is having. Okay, so here we can see in histogram we are having even some outliers also in our data sets. Outliers is nothing but some different amount of data. Okay, so that is outliers. So here we are having, and here they are having an architecture of how they are doing the proposed system, data driven framework, using data driven. So first they are collecting the AMI data. AMI data is nothing but using smart meter, they are collecting the data and they are clustering the algorithm data. After clustering the data, they are trying to classifying the pattern. Okay, but in today's webinar we are going to use the data set with clustering. Okay, how many clusters, that is how many class types are there in our data set. Okay, so this is the model. So one thing I have to tell you, these webinars PPT and these webinars IEEE papers and then some other documents also available in the link. Okay, so if you need those papers and those PPTs, means you just check out our description link. You will have a separate link, document link, so you can use that link and download it. Okay, so this is the basic architecture, basic pattern they are previously used in our base paper. Okay, so now what we are going to do, that is the main thing. So we are going to do this process, that is, now we identified the what is the existing system, and now we are going to use the proposed system. Okay, so what is the proposed system and what is the proposed system block diagram and what is the model we are using in proposed system and UML diagram algorithm. Okay, what is the algorithm we are using? Kmeans algorithm. So what is the uses of that Kmeans algorithm, and we are directly implementing the project. So see guys, we are going to develop the end-to-end delivery machine learning project. Okay, so first we are seeing the disadvantage and existing system in our base paper, and we are going to use a proposed system. In that proposed system, how we can overcome our existing system. Okay, so this is what we are going to see. Now what is the main objective of in this webinar we are going to see? So the main objective of the project is we are going to predict a number of clusters in the dataset. That is, we are having a dataset, but we are not having a dependent column. Okay, so we are having an independent column only, that is the data of the person, who are all person having a monthly income and how much they are paying for the separately for billing amounts, those things are electricity billing amounts. Okay, so how we need to predict those clusters, different type of customers in our data set. So by this is the main objective. So for that purpose we are going to use the algorithm that is called Kmeans algorithm. So first we will see about existing system. So existing system is nothing but they are using the weighted cluster wise regression, that is WCR algorithm. Okay, so they are using this algorithm, but we are going to use today's session Kmeans algorithm. Okay, so first of all we will see about literature survey. Literature survey is nothing but the probabilistic peak load estimation in smart cities using smart meter data. Okay, so that is, I will show you previously what they are done with literature survey. So this is the literature survey paper. So probabilistic peak load estimation in smart cities using smart meter data. Okay, so generally if I need to tell detailing means I am using the pane. Okay, so what they are doing means we have some, for example you can assume that these are some homes. Okay, home, we are having some homes. Okay, so definitely the home will have some electricity lines. Okay, so they will pass some electricity lines to each and every homes. Okay, so we are going to predict the unobservable homes, that is we are placing for this each home we are going to place the smart meters. Okay, using that smart meter we are collecting some data. Okay, so what they are using some smart meters, that we are collecting some data, so those data will be saved in the data set. After we are collecting some data, if we are getting some unobserved activities in this line means we need to predict those unobservable customer. Okay, so for that purpose we are going to predict this output result. Okay, so I am going to, so based on the literature survey, here you can see they are using 4 main stages, like they are using load modeling and sampling by the proposed variable, and then truncated R-wine couple method, and correlation based customer grouping. Correlation based customer grouping means they are, what are the data available in our data set, they are having some attributes. Based on that attributes they will attributes will be checked with each and every attribute, that is they will find the score value of each and every attributes by using correlation graph or correlation score values, and they are normalized with the maximum values, and they are using some method and they are training those things. But in today's thing we are going to propose the system, we are going to predict the number of cluster by using Kmeans Unsupervised Learning algorithm. Okay, so first of all you need to know block diagram. Block diagram is nothing but first we will give the unsupervised learning. So here you can see we are going to use unsupervised learning. Okay, so first of all you need to know what is unsupervised learning. So this is one of the most important. What is unsupervised learning, what is supervised learning, and what is reinforcement learning. Those things are somewhat important thing. Okay, so generally here we are going to use machine learning technique. We are going to use machine learning technique. So machine learning technique is nothing but generally what is the use of machine learning technique means based on the past data it will be give the predictor result. Okay, for example if you are having any past data, based on that past data we will train the algorithm, and after that we are getting an output result. In this machine learning we have some different type of technique like supervised learning and unsupervised learning and reinforcement learning. Okay, so supervised learning is nothing but if you have a data set, for example you can take a data set of diabetes prediction. Okay, so diabetes prediction is nothing but we need to predict, and based on the patient detail we need to predict an output result whether the patient will be attacked by diabetes or not. Okay, suppose otherwise you can take home price prediction. Okay, so based on the location and based on the room size and square feet area, and then based on the city side or it's a village side, like that, if you need to predict the home price, you need to you need to have some details about that home. Okay, so based on that only you can predict an output. This home will be approximately it will become 1.1 lakh or 1.2 lakh, like that, right? So if you need to predict an output, if you have a data set, the data set with output, okay, so the data set with output column, this should be an definitely supervised learning. Okay, so if you have a output column, that is, for example, if you can take it as a diabetes data set, definitely you will be have some detail about patient, and you will be have a output column, that is both dependent value and independent value will be available in your data set. If you have those columns and values, means it's a supervised learning. Suppose if you have a data without output column, that is only you will be have a independent data, there is no dependent data. So generally dependent data is nothing but it's an output column. Okay, so if you have output column, this data set will be called as a supervised learning. If you don't have an output column, that data set will be called as a unsupervised learning. Simply you can take a diabetes prediction. So in diabetes prediction data set, if you have an output column, you can use supervised learning type of algorithm like linear regression or logistic regression. So in supervised learning also we have two type, classification and regression. So based on that, if it is an output prediction column will be an like within range, you can use supervised learning. The output prediction column is without range, that is if you need to predict an home price, suppose if it is a rural area, its home price will be low. If it is a city area, the home price will be a high. Okay, we can't find within range. Okay, so if you have like those things, prediction range means it's called a regression type. So that is called supervised learning. So unsupervised learning also two type, like like clustering and association. Today we are going to use clustering type of technique only using unsupervised learning, and we have association type also. Association type generally used to predict like recommendation system or market basket analysis, like those things and all. But unsupervised learning generally used to predict and classification. Okay, that is if you have a data set without output column, you can use this unsupervised learning. You can try to find the number of cluster, that is number of class in your data set. Okay, so that is called unsupervised learning clustering type. We are going to use this technique only in today's session. And even though we are having a reinforcement learning, so generally you can, for example, you can take like game or any other things, like any other environment. Okay, so suppose generally if you want to tell, simply if you need to tell reinforcement learning means, if I give it to you new mobile, okay, so that mobile is like anything, Android or Android or iOS or any BlackBerry, any other OS. Okay, so if I give any mobile to you, new mobile, so you need to learn about that mobile, how your user interface is there. Okay, so if you want to message to someone means how you need to open message. If you are learned correctly means it's a positive reward, right? Suppose if you don't know about how to open the message application means it's a negative reward. Okay, so you will try to learn yourself. Okay, so based on the environment, so that is called reinforcement learning. So you need to try to learn based on the environment. So that is generally reinforcement learning. So we have totally in machine learning, supervised learning, unsupervised learning and reinforcement learning. So we are going to use unsupervised learning clustering type. So one of the clustering type technique is called as a Kmeans algorithm. So what is the block diagram? So here you can see I am having an input data, but I don't have any output column, output class file. So we are just passing the data and algorithm. Here we will use Kmeans algorithm. Using Kmeans algorithm, we are processing the data and we are going to find the how many clusters in this data. Okay, suppose here according to the architecture block diagram we are having a 0, 1 and 2. So we are having 0, 1 and 2. So we are totally we are having 3 classes. So like that, here I will use one of the data set. I will show you the data set, then only you will be understood. So this is the data set which we are going to use in today's session. This data set link, data sets are available in the link which in description. Okay, use that link and download it. Here we are having the data set like customer ID and gender, age, annual income and spending score, like those things and all. Okay, so using this data set we are going to find the dependent column. Okay, we are having an independent column but we don't have dependent column. We are going to predict the dependent column. Okay, so that is the use of this. So we need to find the cluster. Okay, so next one, model explanation. Model explanation is nothing but like, first of all, data set analysis. Okay, so we already analyzed the data set. It's nothing, we have like these things we are having in data set. And the next one, we need to use elbow method. So what is the use of elbow method and why we are using? About this I will tell you. Okay, and next one, specific number of clusters K, and then next one, initializing the centroid, and after that we are going to keep the iterating until there is no changes with centroid, and assigning the each data point into the closest cluster and computing the centroid. Okay, so let's see one by one about model explanation. First of all, data set analysis. We already know we are having a data set but we don't have any output column. We are going to predict an output column by using Kmeans algorithm. And the next one, elbow method. So first of all, you need to know what is elbow method, why we are using. So why we are using means it will be find the relationship between the number of clusters and within cluster, that is using sum of square. Okay, that is what we are having number of clusters, and based on that we are squaring all the values. Then we will select the number of cluster where the changes will be WSS begins to the level of. Okay, so generally they will call us if you have this data, that is, for example, I will take in today's webinar annual income and spending score. So I will calculate this all the, that is, I will square all the values and I will do some iteration. Okay, like 10 iteration or 20 iteration. Then I will find some data value. Based on the data value, that is, I will find the within cluster sum of square value, that is WCSS. Based on the WCSS, I will plot the graph. Okay, so this is the graph for using within cluster sum of squares. So here I will find the number of cluster where the changes in the graph. Here you can see I am having totally 2 changes in my graph. One is here and another one is here. Okay, so generally this is called elbow method. Here we will find the n number of cluster by using elbow method. Okay, so if I use paint, so first of all I have a data set. Okay, I have a data set but for this data set I am not having column, that is output column. So I need to find the n number of clusters. To find the n number of clusters, first of all I need to find the WCS, that is square value. Okay, so using elbow method, where I am getting the change. For example, here we have elbow method. I am getting the changes here. That is, I am getting a slope value like here, means that is, it means here 1 and 2, 3 and 4 and 5. So in my data set I am having a 5 type of clusters will be there. So that is the use of this elbow method. So here I am having a graph. Let's see the graph. According to my graph, here you can see, here I am getting the cluster value. Okay, so 5. So totally in my data set I am having 5 different type of clusters data, that is class files. Okay, so that is the use of elbow method to finding the number of clusters. After finding the number of clusters, we are going to specify the clusters. So we already find its number of cluster is 5. Then we will initialize the centroid. So what is this centroid? Suppose if I have a data like this, here I will have some data, some cluster of data. So this is one cluster 1, and here I will be have some cluster of data. This is cluster 2. Suppose if I have a 3 clusters, okay, suppose if I have a 3 cluster, I need to initialize the 3 points, 3 random points in the graph. Okay, so generally here it's called as a centroid. Okay, so if I have a n number of clusters is 5, I need to initialize 5 clusters. Okay, so what is the use of this centroid means it will be iterate again and again. Okay, it will be try to assign each data point to the closest cluster. Okay, so that is it will be try to reach the nearest cluster point. Okay, and after this it will be move on to the center of the each cluster. So if it is moved to the center of the each cluster, this is called as a centroid. Okay, so based on this only we are going to predict them. Totally I am having a 3 clusters in my output result. Okay, so this is the use of centroid. I will tell you in detail in technical system. Okay, so these are the models we are going to see. First we are analyzing the data set, and next we are going to use the elbow method and specifying the number of clusters and initializing the centroid and keep iterating until there is no changes to the centroid and assigning the each data point to the closest cluster and computing the centroid. Okay, so just remember about this model. We are going to do this model in our technical session. The next thing, UML diagram. So here we need to start and we need to select the number of centers and set until the cluster reach center randomly. Okay, so we are going to initialize the centers and then put object to the closest cluster center. That is where is the closest cluster center. It's not a mandatory one. Okay, we need to initialize here the center and here you can initialize wherever point. It's not a mandatory one. You need to initialize the center of the position. It will be randomly placed anywhere. Okay, based on that anywhere it will be calculate the cluster center. Okay, so for example this cluster, for this cluster it's a nearest one, right? So it will be go here. For this cluster it's a nearest one, it will be go here. For this cluster it will be this one will be finally only one, so it will be go to here. So it will be recalculate the new cluster center each and every time, and then create a cluster based on the smaller distance, that is smaller distance. Okay, so this is the smaller distance of each cluster. Okay, so like this it will be iterate again and again, then finally we will get an output result of the center position. So that is the UML flow chart. And then algorithm. So about algorithm, so we already know what is we are using Kmeans algorithm. So Kmeans algorithm is nothing but it's an unsupervised machine learning algorithm in contrast to traditional supervised machine learning algorithm. Okay, so Kmeans attempt to classify the data without having the first been trained with a labeled data. That is without training with labels. Generally if you take a machine learning supervised learning type means you will be trained with data and output. Okay, data and output generally if you are training and supervised learning type of algorithm. But Kmeans algorithm is without output you need to train the Kmeans algorithm. Okay, so to find the label. Okay, so any new data can easily assign to the most relevant group. Okay, so the real world application for Kmeans like customer profiling and market segmentation, computer vision, that is OpenCV, and then search engine, and then astronomy. Okay, so these are the area, one of the real-time applications we are using for Kmeans algorithm. Okay, so this is the thing we are going to do in this thing. So how it's work, Kmeans algorithm? First, we need to find the K value. Okay, so the K value is nothing but we need to find the random cluster center called centroid, and then we need to assign each data point to the closest cluster by calculating its distance with respect to each centroid. Then we need to determine the new cluster center by computing the average of the assigned point. After that, repeat it again and again, you will be finally comes to the centroid. Okay, so this is the thing we seen about this thing. Okay, so about what is K-means algorithm, what is existing and what is proposed, those things and all. So the formula for the algorithm is like J is equal to summation of K, that is number of clusters, J is equal to 1 and I is equal to 1, and number of cases n, and then x I power of j, then minus cj square. Okay, so distance function and case and centroid of the cluster. So this is the algorithm for the K-means. So now it's time to see the project demo. Before that, if you have any question and if you have any other doubt, if you have, you just ask it in our comment section. I will explain you. If you have any doubt, you just ask in comment section. I will be give the if you have any doubt, you just ask it in our comment section. I will give any reply to you. See guys, now the theoretical session is over. Okay, now I am entering into the technical part, how we need to apply the algorithm, K-means algorithm, and how we are going to work on with K-means algorithm, those things and all. So if you have any thing and if you have any question, you can ask it now. Where can we download the dataset from? Okay, so actually I will use, after this webinar I will add the dataset link also. Okay, you can download the dataset. If you need dataset like real-time machine learning dataset, you can download it in Kaggle website or machine learning repository like that. So after finding the K values in the K-means, what should be done? Yeah, so this I will show you technically now. Okay, so there is no problem. Now you will be understand this technical session. If you attend this technical part, you will be definitely comes to know what we are doing exactly. Okay. Okay, so let we enter into the session. Okay, technical session, and we will see real-time application. Okay, so what are the K-means real-time application is like. We can do customer profiling. Today we are going to do those thing only. Even though you can use for market segmentation and computer vision and then search engine, astronomy, those things. Which software will be used in the project? So we are going to use like Jupyter Notebook or Google Collab. Okay, so if you are free means you can use Google Collab and then check it out. So if you need, suppose if you need a like, just wait a minute. If you need, those who are need a data set, I will share the data set to you. Okay, so the data set, I am having a data set. I will share the data set link. Just wait a minute. I will share the data set link. Okay. I will update the dataset link in our I will share you now. Okay, so using that link you can download the dataset. I am updating the dataset link. Okay, so those who are need, you just download it. Actually I updated in our description also. Now itself I updated in our description. So please download the dataset. The dataset name is customers.csv. Okay, so this is the dataset. We are having so many dataset in that link. Just download the customers.csv file. After you downloading the dataset in your PC, just enter into your Google Collab. Okay, how to open Google Collab I will tell you. Okay, so those who are free you can work on with me also. So just search it, open your browser and search it for Google Collab. Then you will be get like this page. So click the first link in your PC. Okay. Yeah, registration will be open at last only. Attendance links will be open at last only. Okay, so those who are need attendance link, just wait for till end of this webinar. You will be get. Okay, so please explain the reinforcement learning. No, you need to register for each and every day. See, day by day you need to register. Actually I posted the link in description. Okay, so those who are dataset link, okay, so those who are need dataset, download it, and then attendance links and certificate links will be open at the end of this webinar only. So don't try to open now itself, please open at the end of this webinar. Okay, so which dataset will be you need? So you need to download the dataset customers.csv file. Okay, so those who are entering into the dataset link, just to download the dataset customers.csv file. After downloading the customers.csv file in Google, you just search it for Google Collab. Then click the first link in your web page. It will be enter into the Google Collaboratory. Okay, welcome to Collaboratory. This page here you can create your new notebook file. Okay, so today I am using notebook file, Python notebook file. Okay, so please open your Python notebook file. If you are interested to do with me technical part, just to open Google Collab, just search it in Google. Then after that you will be get some link. So you have to open Google Collab like this and then create your new notebook file and click file option, create new notebook file. Then automatically it will be create a new notebook file. So here only we are going to work on our technical system. So for this I need a dataset. The dataset which I have, I need to upload the dataset. So here also I am downloading the dataset. I am downloading the using that link. I am downloading the dataset. The dataset link available in description. Please download it. After download it, here you can see I am having a customers.csv file. I need to upload this file to my Google Colab file. Okay, so for this you need to click this files option and then upload, then customers.csv open. Okay, so now I uploaded with my dataset to my Google Colab notebook file. Now it's ready to move on technical system. So I move to the next part. Okay, so I will tell again how to open Google Colab, how to download the dataset. So first of all, you need to download the dataset. The dataset link is available in our description. Go click that link, dataset link. Then you will be enter into this Google Drive. Then you download the customers.csv file. After downloading, just open your browser. Okay, after opening your browser, just search it for Collab. Google Collab, then automatically you will be get like this. Okay, just click the first link. After you are clicking the first link, it will be enter into the welcome to collaboratory page. Here you can create your new notebook file. Click the file option and then click the new notebook file. Then automatically the new notebook file will be created. After you are creating this new notebook file, you have to upload the dataset which you are downloading. Okay, so for that purpose you have to upload your dataset. You have to click this icon. After clicking this icon, it will be asked which dataset you have to upload. Just click customers.csv and then open it. Okay, then automatically your dataset will be uploaded in your Google Colab. So here I am going to import some basic packages. Import pandas as pd and then import matplotlib as plt and then import numpy as np. Okay, so if you need like this suggestion, you have to, if you need suggestion, you have to use control plus space button. Okay, it will be give the suggestion. So if you need to run this particular cell, you have to use this icon. Okay, now it's run. Now I need to read my dataset. I am creating a new variable name. The variable name is dataset. Then I need to read the dataset using pandas. I am reading the dataset. pd dot read underscore csv control space. You will be get a suggestion, and then I am using customer. Sorry, I need to upload the, I need to give my dataset name. The dataset name is customers.csv capital C. Okay, so here also you need to give capital C, and then here you can see I am having this dataset. I am uploading dataset. Okay, so anybody have any doubt regarding applying? Anybody have any doubt? You may ask in our comment section. If you register for only one time, it's enough. Don't register for again and again. And the quiz competition will be open after this webinar. So please be ready. It's a easy, very easy question only. This is the first webinar session of this program awareness. Project awareness. So just we asked on few basic questions only. You just check it out and then answer it. Now what I am going to do means, I am reading this dataset. After reading this dataset, I am going to take some important data. Okay, in this dot head, I am having some data. Okay, so here I am taking some important data like annual income and spending. So the main aim of this project is, okay, we are going to predict that n number of classification. So here I am having only an independent column. I don't have any dependent column. So using Kmeans algorithm, we are going to predict an n number of cluster available in this dataset. Okay, so this is the dataset head. We are going to take only these two for our Kmeans algorithm. So I am going to use x is equal to dataset dot ilog and then I am having this 3, 4. 3, 4 is nothing but this first one representing all the rows in your dataset, and 3, 4 is nothing but I am taking particularly these two columns. Okay, so for these two columns I am going to take and save it in x. Okay, so just to run it. After you run this one, Now I'm going to I have to do like print the dataset. Here you can see annual income, those things. Okay, so now I taken particularly this one and this one. Okay, next one I am going to find my clusters, how many n number of clusters. So I am importing from sklearn dot clusters import Kmeans. Okay, import Kmeans algorithm. So here we have different type of Kmeans. We have to import capital Km means algorithm. Okay, I am going to create a WCSS. So what is this WCSS? We already discussed about WCSS is nothing but its weight, that is within cluster sum of square. Okay, within cluster sum of square we need to find. So that's why we are creating an empty list. In this empty list we are going to open for loop. Using this for loop I am using some range of for loop, that is 1 to 10, and then I am creating a new variable name Kmeans, that is otherwise I will use model1 is equal to, I am calling the Kmeans algorithm which I imported previously, and then I am using n number of clusters. So n number of clusters till now I didn't find, so I am iterating 10 times, so I am giving here n number of clusters. Till now I didn't get my n number of clusters. Now I am going to plot the elbow method, so that's why we are writing the code how we can plot the elbow method. Now I am using a init is nothing but initializing the Kmeans here, Kmeans, and the next thing I am using a random state is nothing but giving 0. Okay, then after that I am using my model name, I am saving my Kmeans algorithm with this parameter in one variable, that is model1, and then now I am using model1 is equal to model1 fit is the keyword to train the algorithm. Here I am passing x and I am training the algorithm. So after training I will be get some result, that is within cluster sum of square values. That values will be, I need to save this in empty list, so that's why I am using here WCSS dot append data. Okay, using append. Okay, I need to save all my Kmeans inertia. Okay, I need to save all my model 1 dot inertia. Okay, so now I am just executing this line. After this, if I print this WCSS, I will be get some square value of my input data x. So this is, I am getting some 10 square value g. Okay, why? Because I am doing a 10 iteration from 1 to 10, so I am getting a 10 values. Using these 10 values only I am going to view the elbow method. Okay, so previously we seen about what is elbow method. Here you can see this is the elbow method. Okay, so I am going to plot this graph. Okay, so by using this elbow method I am going to plot the graph. So now I am using plt dot plot and then range. So range, how much I given 1 to 11, right? And then I am going to give WCSS. So I am going to plot the graph. So here I can see I am getting an elbow method. So if you need to give even title or even X label or Y label also you can give, but I am just giving here only plotting of range. So here you can see you can find the elbow method. So here first changes, here I am getting second changes. So every time if you are seeing an elbow method, the second change will be you need to check. So here second changes will be near to the 5. Okay, so in my data set we are having totally 5 clusters. Based on this data set we are having a 5 clusters. So I plotted I take it as a n number of clusters as a 5. Okay, so by using this elbow method I easily find the how many clusters. Okay, plt dot I'm using title I am giving for this graph as the elbow method. Okay, so here I am getting my elbow method. So now you can easily plot the graph. Sorry, you can easily train the algorithm with n number. So now we find the cluster, we have totally 5 clusters. So we need to initialize the centroids, 5 centroids. According to this paint, we are having even more 2 extra clusters. So we need to initialize the 5 centroids. Okay, so how I can apply means using previously I given iteration value. Now I am going to copy this line, but now I am changing some data, that is I am going to change model to, then Kmeans here I am giving as a n number of clusters as a 5. Okay, so apart from this everything is same. Now I am going to use y otherwise dependent data. Our main aim is we need to find the dependent data. So we are going to use dependent, and then I need to use model 2 here. Why? Because model 2 I find out by n number of cluster 5. Then I am going to use fit underscore predict, then I will pass my x data. Then automatically I will be get some output value. So if I print the dependent data, you will be get an output result. Here you can see. So totally I am getting an output result like this. So 3 1 0 1 2 3 4. Okay, so this is the way you can find your n number of clusters by applying this Kmeans algorithm. Okay, you can easily find the method, right? How previously we are not having any, we are having a data but we don't have any dependent column, that is output column. So we taken some important data, and after that I am importing an Kmeans algorithm, and I calculated my square value. Okay, sum of square value of each clusters. Then after finding the sum of square value, then I appended my inertia. Okay, I am appended by inertia value of my model 1 in this list. Then I just viewed the list, I am getting some inertia value. Then after that I using elbow method, I am plotting the inertia value. I am getting the 2 points. So you have to always check the second one. Here you can see I am getting 5. So totally I am initializing as a 5 clusters. Then after that I given all my data, x data. Then it will be predict based on the 5 clusters 0 1 2 3 and 4. So now we get an output result. So now we have a data set with the output column. So now you can use even though supervised learning type of classification type algorithm. You can train the algorithm and you can predict an output result. Okay, so this is the way you can do the process. Suppose if you need to see the data which is available here, you can see by using the graph like this. Okay, so we have the output result using So here I am just using scatter plot, and I am plotting all the centroid. That is, for totally I am having a 5 centroids. The first centroid will be a red, second centroid will be a blue, third centroid will be a green, cyan and magenta. Okay, so cluster 1, cluster 1, cluster 3, cluster 4 and cluster 5. So if I execute this line, I am getting an error. Just wait a minute, I need to change some value x. So x, which I used here small x only, but in my copied code I am having capital X. So here x data, and I am getting an error. Y means is not defined. What is the y? Here I have a dependent, right? I have a variable dependent. I need to use here dependent. So instead of this y means, I am using the dependent. Why? Because I saved my output data in dependent value only. So I am changing this all the y means as a dependent. After this changing, I need to execute the code, and you can see the how it's working. Okay, anywhere is there any y means, I think it's not there. We'll run the code, and again I'm getting an output error. What is the error? Okay, so invalid key. So label is equal to dependent 0 and dependent. Okay, scatter. Okay, means clusters, centroid, everything is fine. I think here I am having an array value. We need to convert as a data frame. Otherwise we will check the output here. Okay, so in Jupyter Notebook I am getting an output result in y means type. If you are checking an y means type of your y means, okay, I am getting an ND array only, but here I am getting an output result correctly, but y means, what is the output plot? Scatter. Okay, x, okay, this also x. Okay, type error. Okay, otherwise you can check the shape. Okay, shape y means y underscore k means dot shape. Shape is just 200 here. If I check here, what is the shape? Dot shape 200. Okay, everything is perfect, even though I am getting an error. Dependent equal to 0. Otherwise we need to, I will run it again from starting onwards. Sometimes it will be get error for this also. Model 2 dependent, and then plotting. Again I am getting error, same type error only. Okay, it's fine. We will be move on to the Jupyter Notebook, and we will see the output plot, graph plot. Okay, so this is the graph plot. You can see based on the 5 cluster, I am getting an output result like this. Okay, so this is this yellow color, which will be called as a centroid, and some other red, blue, green, and then this one cyan and magenta. This will be called as a each and every clusters. Okay, so this is the way you can find your output by without having an independent column. You can find the dependent column by applying this Kmeans algorithm method. Okay, so up to this, anybody have any doubt? You may ask. Okay, so attendance links available. Okay, up to this, anybody have any doubt regarding this, you may ask using your comment section. Dependent variable needs to rename. Yeah, already renamed that one. You have dependent instead of. Okay, just wait a minute. I will check it out. Dependent variable D. Okay, X. Some third line of your typed extra yes, 1 2 3 here, extra yes. No, it's showing actually how we will check it on Stack Overflow. Values. Okay, X we are passing here. X also, it's what is that shape type of the X? Type X pandas core frame. Yes, this is the matter. We are getting an output error, I think so. It's in pandas core frame, and here we are getting. Here we are passing core frame, and here we are having an what is that shape? Array frame. Okay, so now what I am doing here, X equal to X dot values. Okay, X equal to X dot values. So what is the use of this values means, here I am having the type pandas core frame data frame type. I can convert my core frame type into an array type. Okay, so if I execute this line, and then if I use type X, then I am getting here numpy and nd array. Okay, so now X also numpy and nd array, and my dependent variable also numpy and nd array. If I execute the output, what I am getting, you can see. Now the name error is here only. Here, what is the error? Kmeans. Okay, so Kmeans is the error. Why? Because I used here model 2. Okay, now I am again Kmeans. So where I am here model 2, I need to change model 2. If I execute the line, I am getting an output result. Okay, so now you can see why I am getting an error means, X data in the form of core frame, pandas core frame data frame type. This is one of the pandas frame type data type, and dependent data in the form of array value. Okay, so I am passing array value and I am passing the data frame value here. So that's why I am getting a type error. So if you are getting like this type error, true or false, like those things means, you just check the type which you are passing for in your variable. Okay, so both the variable you need same type. So I changed my X value as a pandas core frame type into an numpy type, that is array type. Now if I execute this line, I am getting an output correctly. Okay, so this is the one of the mistake I did. Why? Because I just copy paste my code, previous code, so that's why I am getting. Now it's perfectly working. Okay, so this is the way you can find the clustering. Any other doubt? I prefer for machine learning. If you are learning newly, okay, machine learning means, for machine learning I prefer the language Julia. Okay, so Julia is one of the most important language upcoming future. So I prefer you to learn Julia language. Yeah, the error is rectified, the graph also viewed easily. Okay, so if you need these documents, PPTs and base papers, you have a link, document link. You just click the description and you can get the documents, and the attendance links also available in the description. If you need certificate, you can just apply for your certificate using that attendance link. And you have enquiry form also, separate link. You have enquiry link. Using that enquiry link, if you have your own concept, you just tell about your own concept. We will work on it and we will approach you after working on your output result. And even though we have a separate quiz certificate, that is quiz competition also, quiz competition. If you need means, you can use that one, and then you can get a special certificate if you are giving some question 5 out of 5. Totally we are asking 5 questions. For 5 out of 5, if you are asking the questions, you will be get a special certificate from us. So you can use the quiz competition using link below description. And if you are new to this channel, please subscribe the channel and hit a bell icon. You will be get a notification, and attendance links will be open. Try to use the websites like Chrome website. It will be open definitely. And if you are like this video, please hit a like button. It's reached almost 150. Please click a like button. It will be useful for us. So tomorrow yeah, once you're done with your registration, that's enough. Okay, the done. Okay, any other doubt regarding this webinar you may ask. And attendance link for the certificate, and then enquiry form. If you have a new project ideas, you can use enquiry form link. And then we have document link separately. If you need the document, you can just click the link of your document, it will be available. And then certificate also, quiz certificate you need means you have to answer for all the question correctly. Okay, so please check it out. Now everything is done. Project demo also. Next, about us. So we have services like project, final year project, mini project, and research project also for PhD or for like PhD, MBA, MCA, okay, and MTech, okay, and BTech also available. You can contact us. And training, we have internship, certified training like STP and workshop, FDP we are giving for training process also. And products, we have lab kits and hobby kits and IoT models and all we are having. And then thanks for attending this wonderful webinar. And if you are like this webinar, please hit a like button. And if you have any queries about this webinar, please use the enquiry form and you can fill out the queries. And we have different type of branches are available. In Chennai we are having in T Nagar, and in Coimbatore we are having in Gandhipuram, and Hyderabad we are having in Mirpet, and Vijayawada we are having like beside of data complex Vijayawada, and then Trichy we are having Tillai Nagar. Okay, so we have different type of branches are available. Which is your nearby branches, you please contact the branches. We have separate mobile number for each and everything, just to contact it. And thank you all, thank you for this wonderful webinar, and we will see you on tomorrow's new technology webinar. Thank you all. So who are all attend the quiz competition, the winners will be tell at the tomorrow's webinar. Okay, so please attend the quiz. Thank you all. If you have a link, we will share you. After this webinar, please check the description. All the links are available. Check it out. Okay, so thank you so much. Thank you all.